Okay, everybody, Mr. Moon here, giving you some help with the electronic winter break packet, which I am sending out on December 28th. You guys have like 5 days before it's time to come back to school, and this packet has four sections with between 3 and 5 questions each. So if you do one a day, you'll definitely have plenty of time to finish that up. I hope you've already been working on the printed packet that I sent home with the refreshed material for the quiz that we'll be retaking when we get back. Anyway, let's go ahead and get started. The first section of this electronic packet is called Our Nearest Neighbor, and the first question indicates that the diameter of the Earth, which is stated at 7,915 miles, is 7/25 of the diameter of the moon. So we're going to take that 7,915 and we are going to multiply that times 7/25, which that will give us the actual diameter of the moon. So we're going to set this over 1. 7,915 over 1 times 7/25. When you do the math on that, you're going to find out that the numerator is 55,405, and 1 times 25 is, of course, 25. Now, the first thing that we should notice is both that numerator and that denominator end in 5, which means that both of those numbers are divisible by 5. So my next step that I did was divide them both by 5. So that numerator becomes 11,081, and the denominator becomes 5. And when you work that out, you discover that 5 goes into 11,081 exactly 2,216 times, and then there is 1 remaining over the 5 that's already there. So that tells us that the diameter of the moon is 2,216 and 1/5 miles. Next question indicates that the gravitational constant of the moon is 4/25 that of Earth. And we're told that the gravitational constant on Earth is 9 4/5 meters per second squared. And we're going to multiply that times 4/25. All right, so the first thing we're going to have to do is convert that 9 4/5 into an improper fraction. So you do 5 times 9, and then you add that. You do 5 times 9, then you add that to the 4 that's already there. So 5 times 9 is 45, and then you add the other 4, you get 49 over 5 times 4/25. All right, you've got your 49 over 5 times 4/25. Next thing you're going to do is multiply straight across. What that's going to give you is 196 over 125. You pull your 125 from the 196 one time, and you're left with 71, and your denominator is still 125. So the gravitational constant on the moon is 1 and 71 1/25. All right, so you select that answer. The next question says, in the second experiment, we used weights on the ship and weights of equal mass here on Earth, and we dropped them from equal heights. And then it asks you, what are the constants? Well, it just told you that the mass of the weights were the same. It explained that the mass was the same, and then it also told you that they were dropped from equal heights. So you've got the mass of the weights and the heights from which they were dropped. Those are your two constants in that experiment. Moving on to the next section, which is called, oh no, the warp engine is malfunctioning. The first question indicates that the distance where you are now from the sun is 1 and 13/25, so a little bit more than 1.5. 1 and 13/25 times the distance the Earth is from the sun. So we're going to use million miles as a unit here. million miles. Instead of just miles, it's going to be million miles. It's going to be the unit. So we're just going to work with the 93. You see the Earth is 93 million miles. Instead of writing 93 million, we're just going to do 93. All right, we're going to set that over 1. We're going to multiply that times our 1 and 13/25. So again, we need to convert that 1 and 13/25 to an improper fraction. And what that's going to become is 38/25. We're going to take our 25, multiply it times 1, then we're going to add that to 13. So 25 times 1 is 25, plus 13 gives us 38. So we got our 93 over 1 times 38 over 25. All right, next thing we're going to do is go ahead and multiply straight across. Our 98 times 93 times 38 becomes 3,534. And that's still over the same denominator, which is 25. You find out that 25 goes into that 3,534 141 times, and it leaves a remainder of 9. So you put that 9 back over the denominator that's already there, and we find that the distance where you are now to the sun is 141 and 9/25 million miles. All right. And then we got another question about the gravitational constant. 2/5. The gravitational constant where you are is 2/5 the gravitational constant on Earth. So we're going to take our Earth's gravitational constant, 9 4/5 meters per second squared. Multiply that times 2/5. We have to convert this to an improper fraction, so 5 times 9, and then take that and add 4. And what we end up with is, again, we already did this calculation, 49 over 5 times 2 over 5. And that's going to give us 98 over 25. All right, with that 98 over 25, we're then just going to convert that back into a mixed number. You know that 25 goes into 75 3 times, and then to get to the 98, there's still a remainder of 23, so that's over 25. So our answer for the gravitational constant where you are now is 3 23/25 meters per second squared. The next question says, in that experiment where we dropped weights again, what is the independent variable? What is the thing that was changed by us? What was changed by our actions? And the answer to that is gravity. You're on a different planet, so the gravity is different. The gravitational constant is different, and that is what we changed. And remember, independent variable begins with the letter I, so that's how we know that that's the one that we are changing. I change it. Independent variable. Okay? Now, the next question says, based on the information given, what is your current location? So we know our distance from the sun is 141 and 9/25 million miles. And we know that our gravitational constant is 3 23/25 meters per second squared. So when you look at the information given in the chart that's there, you can easily see that you are on Mars. All right, moving on to the next section. That's a big cup of ice. Now, this one's set up a little bit different. It's telling you that the distance between the Earth and the Sun is 3/100ths of the distance where you are, now on the planet where you've landed on. So what this is asking us is the distance between the Earth and the Sun, which happens to be 92 and 9/10 million miles, is 3/100ths of a number of what size? This distance is 3/100ths a number of what size? So this is what we're trying to figure out now. So this question is set up a little bit different. Of course, we still have to start by converting our 92 and 9/10 to an improper fraction. So 10 times 92 plus 9, the answer to that is going to be 929 still over 10 divided by 3/100. Then we're going to multiply it times the multiplicative inverse of this number. So now we have 929 over 10 times 100 over 3. Once we have figured that much out, we're going to move right along to actually making the calculation. So you're going to multiply straight across and get a really big number there. But of course, all you have to do is just add the zeros behind the 929, put the 2 zeros in, put your comma in, over 30. All right. Now, what I'm going to do next is just divide both of those numbers by 10, because I can see easily at a glance that they are both divisible by 10 because they both end in zeros. So we're going to end up with 9,290 over 3. Now I'm just going to, instead of actually doing the long division, which I invite you to go ahead and do the long division, I'm just going to do some goes intos here. So I know that 3 goes into 9 3 times. I know that 3 goes into 2 0 times. So that means I got to hold on to that 2. So now I've got 29. 3 goes into 27 9 times. So that means I have 2 left over. Okay, so now I've got 20 here instead of 90. And I know that 3 goes into 18 6 times, and that leaves 2 left over out of the 3 that I need. So the answer is 3,096 2/3 million miles. All right, so there's not that exact answer there, but there's one close to it, so we can use that to figure out whether it's A, B, or C. Next question is asking, on the planet where you're currently located, the gravitational constant appears to be 1 3/20 the gravitational constant of Earth. So we're going to take our 1 3/20 and multiply it times the gravitational constant on Earth, which is 9 4/5 meters per second squared. Got to convert both of these to improper fractions. So we've got 20 times 1 plus 3, which gives us 23 over 20. Now we've got 5 times 9 plus 4, which gives us 49 over 5. All right, we multiply straight across. We end up with 1,127 over 100. And then once you pull those hundreds out of that 1,127, you end up with 11 27/100. And that answer is right there for you to pick. Okay. Then it says in the second experiment, we're still using dropping weights to figure out how fast they fall. What is the dependent variable? So we know the things that are the same are the mass of the weights and the height from which we're dropping them. The thing where we've changed the gravity by putting them on different planets. So what is it we're waiting to see? And that's going to be the duration of the drop, the time that it takes for the weights to get to the ground. That's our dependent variable. All right, and then the last part of that, it's asking, so what location are we actually at? And if you look at the distance from the sun and the gravitational constant, the only choice that makes sense there is planet Neptune. All right, so we still got to get you home. Let's keep working towards it. We're on the last work page now in this packet, which is called Fried Eggs on the Ground. Okay, so now this question is telling us that 57 is 1/20 a number of what size? So we're going to set our 57 over 1, And then we're going to multiply that times the multiplicative inverse of the 1/20th. So we've got 57 over 1 times 20 over 1. We can use unit form because there's a common denominator. We can eliminate the denominator, and all we have to look at is 57 times 20. All right. So we know that 57 times 10 is 570. If we just double that 570, it's real easy to do that one. And we find out that our answer is going to be 1,140 degrees Fahrenheit. That's a degree sign, degrees Fahrenheit. All right. Moving along from there, the next question is telling us that the gravitational constant is 2/5 of the gravitational constant here on Earth. Now, we did a question exactly like this one before, but let's go ahead and work it out. We've got our 9 4/5 times 2/5, which becomes 49/5 times 2/5, which when we multiply straight across becomes 98/25, which is 3 and 23/25 meters per second squared. All right, that answer is there for you. Then it says when we were checking the temperature, what kind of data were we getting? We got the data in a set number of degrees Fahrenheit, and the fact that it was a specific number makes it quantitative. All right, TIVE. That is a quantitative empirical observation. It'd be qualitative if we said, hey, it's hot. But the fact that we put a specific number on it makes it quantitative. And meditative is not a type of empirical observation. So I hope no one picked meditative. Then when you look at the chart, you realize the only planet that you could be on, or the only location you could be in our solar system, is planet Mercury. And that is the answer there. And with that, we're all done. I hope everyone did a great job on these, and take it easy. Bye-bye.